Hi folks, my name's Jeff Rugrock, and this is the second video in a short series of videos regarding stack risers or diagrams. Throughout the PowerPoint presentation, if you were taking notes, as I have done here, I made a note of the different terms we've been looking at and the terminology, sizing, descriptions, outlier notes, and then some description of whether it was upstream or downstream. Those are the things we looked at in the PowerPoint, and now I'm just simply asking you to draw the speaking notes into a sketch of some description. This happens to be the one from the textbook, which is Michael Joyce Blueprint Reading and Drafting for Plumbers. Primarily, not all of it, but primarily it was based on Chapter 7, riser diagrams, which I often referred to as stacks. And that includes all the definitions associated, building drain, building sewer, and so on, and then some sort of a drawing that complements it. For my drawing, I'm using a house, 1, 2, 3, 4, I guess this would be considered a 2.5 story building. Half story, second story, first story. For plumbing purposes, if there was plumbing in the basement, it would actually be, the first story would be the basement, because the story is defined as something with a plumbing in it. And I'm just going to add all the components from the lecture presentation onto this drawing. The first thing I'd like you to know is if you're using a pre-existing drawing, you don't square up to the page or the border, you square up to the drawing itself. So when you go to fasten it down to your table, and I have this kind of sort of half set up here. Oops. You make sure that your page is set to .30 degrees in this case, because I'm doing isometric. You're not obligated to do isometric for this. There we go. Now I have been noticing a lot of students don't use the T-square set square combination along with the painter's tape to hold your page down. That's just painful. I don't know why you would do that. But if you do, one of the things I discovered might help you. So this was riser or stack diagram. And we're using a scale of 1. I'm not actually going to measure these pipes, but this house drawing is drawn at 1/8 scale. So that's where 1/8 of an inch on the page equals a foot on the job. And this is drawing number 1. So think of these drawings as just PowerPoints. I'm going to run my building drain on the open side of the house so you can see it. If I put it in the middle, it'll kind of disappear a little bit. So I'm just going to put it on the open side of the house. It's important to remember that 1 meter outside the building, it changes its name, the building sewer, building drain. And then the uppermost, the most upstream stack is usually a soil stack. So I'm just going to draw that through here. These are hidden lines, by the way. I'm just drawing my vents as a solid line, otherwise you won't know the difference between a hidden line and a... Move bit higher. There we go. So the difference between a hidden line and a vent line is absolutely nothing. So in this case, I'm going to draw my vent piping through the roof here, the vent terminal. I'm going to draw this as a solid line, and then this dashed line is what's hidden behind the roof or hidden behind the floor. Anyway, so this is going to be my terminal stack. And if you recall, a terminal stack is 3-inch. You can call it a main stack if you will. Main. And this is going to be my vent through roof or terminal, vent terminal. So whichever terminology you'd like to use, and that's also 3-inch. And then I'm going to make this my this piping here. I'm going to make this a soil stack. So as an example, let's see here. Let's put a toilet 1/8 of an inch per foot. So let's put a toilet, say we'll go 7 feet out from that way and 4 feet out from that way. So this would be a bathroom wall somewhere. So there's my toilet flange, and it would go down through the floor. And then might go, let's see here, down through the floor. Then I'm just going to come back over here. And again, I'm doing this for visual purposes, but I'm running a drain pipe along my outside wall, which I normally wouldn't want to do for fear that it would freeze. So this would be a WC. Three-inch for FUs. That's the hydraulic load. And of course you might have a sink attached here as well. Perhaps where it comes. And again, I'm drawing this on the outside wall for illustration purposes. You would not necessarily do this. So this would be a lavatory. So now we have a little powder room here. Lavatory, 1.25 inches, and 1 FU. There we go. Which makes this a soil stack, 3-inch soil stack. This would be a 4-inch building drain. Have a clean out here. This would be a 4-inch building sewer. And then who knows, depending on the number of fixtures you have, you might need something bigger, and this is 1 meter outside the building. Yep, so 1 meter outside. So there's that one. So we have our terminal our vent terminal, or vent through roof. We have our terminal stack, which is a 3-inch main stack running all the way through the building. If you will, this is on top of some drains. So not only is this a terminal stack or a main stack, but this is also up here, stack vent. Remember stacks vent? That's also a stack vent. And then you have the soil stack, which carries the waste from any type of fixture, including sanitary units. Clean out at the base, building drain from the most upstream downstream to the building sewer, which would go to a place of disposal. Now I'm just going to add a waste stack. And I'll put that on this corner. When you're drawing isometric, diagonal corners, and I'll show you this in a moment. So this is a vent through roof, but it's here below the roof in the hidden lines where it has to change to 3" because I'm just going to put a small fixture on here. So 3" vent through roof or terminal, vent terminal, whichever you'd like to use. For this I'm going to put, I don't know, maybe I'll put a sink on each floor. And again, my drain pipe's going along the outside wall, which is a no-no. At least for me it is. I once had a building inspector who let me put a water line in an outside wall, sorry. I could not believe that. And then maybe I'll put a bathtub. There. So when you're drawing an isometric diagonal, you're not allowed a T there, and you're not allowed a T there. So you have to change this to a Y. And what I'm going to suggest you do is you just come back here a little bit. So I'm coming back 6 inches. And then come back here 6 inches. And now you can draw an actual triangle. And here I'm going to come back a foot. And a foot. And if you recall, when you have 2 equal sides of a triangle, it is 45 degrees. So then I'm just going to draw it square as I have, and then cut that little bit off. And now we have a right angled triangle. Then, and I'm gonna, I grabbed the black marker, but I like to use color codes from the job site. And on the job site you will find that sewer pipe is often green and hot water pipe is often red on a job. And that includes the piping materials themselves, but also color codes used by the city. Green is often drainage, and red would be wires, but cold water would be blue. So anyways, I'm going to stick with the green for my color coding. And then what that looks like is something like this. You can see it shows up very good. And if you were to add water piping here, you could use red then for hot water without creating an absolute horrid mess out of your drawing. But anyways, going back to these diagonal lines, once you've got them drawn with the ink, you can then start erasing stuff, right? there's your diagonal lines. So in this case, that 45-degree Y with a 45-degree elbow, it looks vertical. And in this case, the 45-degree Y with the 45-degree elbow looks horizontal. And that can happen. The same can happen if we were to connect one of these fixtures, which I'm not going to do because it wouldn't be entirely right. Anyway, so now that we're color coding, we can actually use our dashed line for event. So, this is considered a drain pipe because it has waste in it. Then from above here, these are all my different sinks. You can start cleaning things up as you go. I'm not going to do every little detail here, but on this floor I might have a lav, which is 1¼ inch waste, and 1 fixture unit. And here I might have a kitchen sink, which is 1½ inch waste, 1.5 FUs. And then here I might have, oh, I don't know, a laundry tub, which is 1½ inch waste, 1.5 FUs. And then this might be a bathtub, 1½ inch waste, 1.5 FUs. What you cannot have on this pipe would be a water closet. You would absolutely not be permitted to have a water closet on here because this is my waste stack. By the way, that little isometric crosshairs, that's just the point at which it might come through the floor. I didn't measure this one, so I actually don't know, to be honest. So you can put a big X through there and say not permitted. And that's because this is a waste stack. Anyways, I'm going to carry on finishing this. I got some cleanouts and whatnot to put on. Actually, that one's not going to work. I'll put a line cleanout on here, I think. Clean out. You can put a little cap on there. Anyways, I'm going to go ahead and finish this drawing up, make it look beautiful. Yes, I am. I have to have a clean out on my building drain. Right by where it exits the building. I could have put it here too, there was room for it, but it would have gotten a little cluttered. Anyways, I'm going to go ahead and carry on. But the point here is to take all those lecture notes that I've given you and turn them into a little drawing or PowerPoint, if you will. If you were good with lecture notes, I guess you could just write it all out, but usually it helps to have a visual. Hope that helps. My name is Jeff Rugrock, All Things Prints this semester, and I'll see you next time.